Hey guys, welcome back. Now let's get started with our day 17 walkthrough. You guys can go ahead and read the story here. So coming to the learning objectives. Gain knowledge of the network traffic data format. Understand the differences between full packet captures and network flows. Learn how to process network flow data. Discover the Silk tool suite. And gain hands-on experience in network flow analysis with Silk. Network communication and traffic are the natural behavior of today's interconnected computing world. The behaviors represent a constant data flow of daily activities, including personal interactions and business transactions. The data flow offers invaluable network management, troubleshooting, incident response, and threat hunting insights. The table below highlights the importance and key benefits of each of these aspects. Network management, monitoring network performance, identifying bandwidth bottlenecks, and ensuring resource allocation and quality of service. Troubleshooting, identifying network issues, validating configuration implementations and changes, and setting performance baselines. Incident response, incident scope, root cause analysis, and assessment of the compliance aspect of incidents and day-to-day operations. Threat hunting, proactive analysis for signs of suspicious and malicious patterns, potential threats, anomalies, and IOCs. Also, behavior analysis is used to detect intrusions and insider threats. Network traffic comes in various data types and formats. Packet capture format is the first thing that comes to mind. It provides a granular, raw, and comprehensive view of the network traffic. This format provides all possible data represented in packets in a ready-to-investigate format. Therefore, it is an invaluable artifact for network-level operations. However, this intensive resource needs storage, processing, and analysis capacities to provide comprehensive insight into network traffic. In other words, while PCAPs are very useful for detailed analysis, they are not practical for fast analysis situations as they enclose the actual payload. This situation becomes a pain point when large amounts of data need to be analyzed. The data richness and the level of detail provided by the PCAP format come with the payload it carries. At this point, it will be possible to speed up the process considerably by running the analysis process on a data format that doesn't enclose the payload data. As a result, it will be possible to process more data in a shorter time with fewer resources, leaving more time for analysis and decision making. Network flow data is a lightweight alternative to PCAPs. It's commonly used in NetFlow format, a telemetry protocol developed by Cisco that focuses on the metadata part of the traffic. In other words, it provides only the summary of the traffic. The details appear similarly to how call details appear on your phone bill. Once again, there are no packet contents details with this format. This is why storing, processing, and analyzing this data format is easier than it is with PCAPs. This table here differentiates between PCAP and network flow. You can go ahead and read it. How to collect and process network data. Network data collection and processing typically involves using network monitoring and analysis tools to collect information about the traffic on a network and then analyze that data to gain insight, troubleshoot, or conduct blue and purple team operations. Also, product and system-based solutions will help collect network data in flow format. The specific tools and methods you use will depend on the size and complexity of your network and your objectives. Silk, or the System for Internet Level Knowledge Tool Suite, was developed by the CERT Situational Awareness Group. It contains various tools and binaries that allow users to collect, parse, filter, and analyze network traffic data. In other words, Silk helps analysts gain an insight into multiple aspects of network behavior. Silk can process direct flows, PCAP files, and binary flow data. In this task, you will experiment using Silk tools on binary formats to help the SOC teams achieve their goals. The Silk suite has two parts, the packing system and analysis suite. The packing system supports the collection of multiple network flow types and stores them in the binary files. The analysis suite contains the tools needed to carry out various operations on network flow records. The analysis tool also supports Linux CLI pipes, allowing you to create sophisticated queries. The VM contains a binary flow file, suspiciousflows.silk, in the desktop directory. The next step is discovering the details of the pre-installed Silk instance in the VM. Use the commands provided to verify the Silk suite installation. Use the following command to verify and view the installation details. Silk mainly works on a data repository, but it can also process data sources not in the base data repository. By default, the data repository resides under the var skill data directory, which can be changed by updating the Silk's main configuration file. Note that this task's primary focus is using the Silk suite for analysis, therefore we will only use the network flows given by the SOC team. One of the top 5 actions in the packet and flow analysis is overviewing the file info. Silksuit has a tool, RW file info, that makes this possible. Now let's start working on the artifacts provided. We'll need to view the details of binary flow files using the command below, rf file info and the file name. Now you should see the Silk version, header length, and the total number of flow records and file size. rwcut reads binary flow records and print those selected by the user in text format. It works like reading and filtering tool. For instance, you can open and print all records without any filter or parameter as shown in the command below. Note that this command will print all the records in your console and stop at the last record line. Investigating all these records at once can be overwhelming, especially when working with large flows. Therefore, you need to manage rwcut tool's output size using the following command. So this command here will show the first 5 records. So if you want to see the last 5 records instead of num, you can use tail. Now let's discover the filtering options offered by this tool. Recheck the output. It is designed by column categories, meaning that there's a chance to filter some. rwcut has great filtering parameters that will help you do this. At this point, the fields parameter will help you extract particular columns from the output and make it easier to read. As you can see here, we are using fields and we are specifying which all columns we want to see of the first 5 records. One more detail to pay attention to before proceeding. Look again at the rwcut terminal above and check the protocol column. You should have noticed the numeric values under the protocol session. This column shows the used protocols in decimal format. You'll need to pay attention to this section as Silk highlights protocols in binary form. So here, 6 stands for TCP and 17 stands for UDP. Filtering the event of interest, RW filter. We have covered how to read and filter particular columns with rwcut, but we'll need to implement conditional filters to extract specific records from the flow. RW filter will help us implement conditional and logical filters to extract records for the events of interest. RW filter is an essential part of the Silk suite. It comes with multiple filters for each columns in the sample you're working on, and it's vital for conducting impactful flow analysis. However, even though RW filter is essential and powerful, it has tricky detail. It requires its output to be post-processed. This means that it doesn't display the result on the terminal. The command is missing filtering and passing output options, which is why it didn't provide any result in return. Let's explore the essential filtering options and then pass the result to rwcut to view the output. Let's start by filtering all UDP records using the protocol filter and output processing options. So this command filters all the UDP records with the RW filter, passes the output to the rwcut and displays the first 5 records with rwcut. This section must be set to process the output with the pipe and rwcut. Quick statistics. RW stats. Up to this point, we have covered fundamental tools that help provide some statistics on traffic records. It's now time to speed things up for a quicker and more automated overview of the events. Before you start to work with RW stats, you need to remember how to use the fields parameters we covered in the RW filter section to fire alternative filtering commands for the event of interest. If you need help using these parameters, return to the RW filter section and practice using the parameters provided. So here in this command, the value section shows the measurement in flows, packets and bytes, and these two fields will show the unique number of IP addresses that have used these fields. Let's start this by listing the top talkers on the network. Check the bytes column. We have revealed the traffic volume distribution and identified the top 3 talkers on the network. Let's list the top communication pairs and get for meaningful enriched statistical data. So here, look at the bytes and record columns. These 2 columns highlight where the majority of the traffic originates. Now the top talkers stand out since they are creating the majority of the noise on our network. Remember what we found in the last part of the RW stats. The high traffic volume is on port 53. Let's focus on the DNS records and figure out who's involved. Here we filtered all the records that use port 53. The output shows that approximately 99% of the DNS traffic occurred between these 2 IP addresses. That's a lot of DNS traffic, and it's abnormal unless one of the hosts is a DNS server. Even though the traffic volume doesn't represent ordinary traffic, let's view the frequency of the request using the following command. Red flag. Over 10 DNS requests in less than a second are anomalous. We should highlight this communication pair in our report. Note that we filtered the second talker as it's the source address of the first communication pair. Let's look at the other IP with the same command. The second command provides 0 results, meaning that the second IP didn't send any packets over the DNS port. Note that we will elaborate on these findings in our detection notes. One final check is left before concluding the DNS analysis and proceeding to the remaining connection pairs. We need to check the host we marked as suspicious to see if other hosts in the network have interacted with it. Use the following command. So here we have found out one more IP address interaction. So now let's try with that again. There are 4 records on UDP 123. We can mark this as normal since there is no high volume data on it. Remember, UDP port 123 is commonly used by the NTP service. From the volume, it just looks as it should. Up to this point, we have revealed the potential C2 over DNS. So now let's go and fire up our machine. Okay, so coming to the first question, which version of Silk is installed on the VM? So here we have a version, let's copy this. What is the size of the flows in the count record? So here we have the answer, let's copy this. What is the start time, S time of the 6th record in the file? Okay, so now let's type the command. What is the destination port of the 6th UDP record? So here we have the destination port. Let's check off the 6th record. So that is, let's copy this. What is the record value of the destination port 53? So here we'll have to use the rwstat. Let's write this command. So here we have an answer. Let's copy this. What is the number of bytes transmitted by the top talker on the network? So now let's copy this command. So now let's copy this. What is the IP address of the host that the C2 potentially controls? So let's copy this here. Which IP address is suspected to be the flood attacker? Let's quickly read the last section. Now let's continue the analysis to discover if there are any more anomalies. Remember the quick statistics where we discovered the massive volume on the DNS port? That section also highlighted the volume on port 80. Let's quickly check who is involved in that port 80 traffic. We listed the connection pairs that created the noise. Let's reveal the one that has created the load by focusing on the destination port. So as you can see here, this is the IP. We have now listed all the addresses that use port 80 and revealed the address ending with 223 was the one that created the noise by sending request. We don't have the payloads to see the request details, but the flow details can give us some insights about the pattern. Let's view the frequency and flags of request to see if there is any abnormal pattern here. A series of SYN packets sent in less than a second needs attention and clarification. Let's view all the packets sent by the host first. So now we are filtering that particular IP. Look at the results. No acknowledgement packet has been sent by that host. This pattern is starting to look suspicious now. Let's take a look at the destination's answers. The destination address sends SYN-ACK packet to complete the three-way handshake process. That's expected. However, we have already revealed that the source address only sends the SYN packets. It's supposed to send the acknowledgement packets after receiving the SYN-ACK responses to complete the three-way handshake process. That's a red flag and looks like a DOS attack. But we still need to check if this host has interacted with any other host on the network using the following command. Luckily, there are no further interactions, so we can conclude the analysis and elaborate on the findings in our notes. What is the send SYN packets number of records? So here we can see the number of records. Let's copy this. So now we have completed our day 17 walkthrough. Thank you for watching my video and stay tuned for more.